Hey everyone, I wanted to go over the activity that we did in class using data to understand how to do statistics in AP Biology. Now this first page that you all have in your notebook is just the material that you had in the flipped assignment. Please watch that video if you did not have a chance to do so. In this video, instead, I'm going to focus on the actual data numbers that we used in class. So let's practice together. We're going to start with that standard deviation. And in the first part, you are asked to look at some data from test averages. And so we're going to practice putting these test averages using the helpful hints that you have right here, which are also available on the handout that was given in class. So the first thing that you are told is to place the class mean on the graph that is right here. So the class mean is represented by the average, which would be the middle of your data. And in the data set that you were given, the class average was a 73. So I have placed the mean, which is represented with 0, and then the grade of 73 up here on top. Now in the data set you were given, they told you that the standard deviation is 10. What that means is every time we move to another break here, another line, another category, each value will be increased by 10. That number is different based on the data set that you were given, but in this example, we're going to use an even number of 10 to show to calculate what should be at these marks. So I'm going to go ahead and fill in what these units are down here. So from the mean, if we go one standard deviation above the mean, we would write it as +1. And then if we go one standard deviation below the mean, we would write it as -1. We can also go 2 standard deviations above the mean, as well as 2 standard deviations below the mean. Now that we have that part labeled, let's talk about the grades that would go at the top. So every time we move over one of these sets, or one of these categories, if you want to call them, brackets, our value is going to increase by 10. So to go one standard error of the mean above, or one standard deviation above the mean, we would take the mean, which is 73, plus 10, and that would give us 83. If we go one standard deviation below the mean, then now we're subtracting our value. So we would take 73 minus 10, which is 63. And we do the same thing for +2. Now, not only are you going to add 10 once for this area, you're going to add another 10 here. So that would make this value 93, and that would make 2 standard deviations below the mean 53. Now what you're going to do is you're going to use data to see where your hand size lies on hand distribution for our class. So it says here to enter the data into a Google form. You're not going to do that. We're just going to use previous year's data, and that was given to you on the data set at your table. So you were told that the average hand size is 17.5 centimeters. And you were also given that each standard deviation rounds up to 2. It was actually like 1.9698. So I'm just rounding it to 2. And so now we're going to fill in the data on this chart down below the same way we did with the data above. So first I'm going to label my x-axis, and then I'm going to place my values starting with the average, which is 17.5 at the top. Now, when I go one standard deviation above the mean, I'm going to add 2 centimeters to this value. And then one standard deviation below the mean, I'm going to subtract that value. Now to go 2 standard deviations above the mean, I'm going to add an additional 2 centimeters to this value right here. And I'm going to subtract it as well. So now you can look at the data and find out where your own measurement falls Are you right on the average? Are you within one standard deviation? Are you between 1 and 2 standard deviations? Are you higher than 2 standard deviations? Are you lower? And so this idea kind of gives this data gives us an idea of where our data points fall and how far a data point is from the average. Now for the next part, we're going to be looking at standard error of the mean. And you should have watched the flipped video on what standard error of the mean is and how to interpret it. That is not this video. In this video, I'm just going to be going through the answers that were the actual data that you were given. So in practice problem 1, we're going to be looking at the difference between the size of hand for people with with 2 X chromosomes and those with an XY. And so you're asked to graph this data and find out if there is a statistical difference between these two. So once again, the data is given to you on the sheet in class. And so I'm just going to go ahead and graph that information. I'm going to start by creating the bar graph. I think that's the easiest part for students to start with because it's a skill you've already done before previously. So keep in mind from what you learn from the lab template rubric, to help you remember and earn all the points on graphing, we use the acronym SAD, Scale, Axes, and your data. Now, College Board will typically give you a graph like this that is a 20 by 20 grid. It's very helpful to remember that it's 20 by 20 so that you don't have to use up time counting how many lines there are. So the first thing that I'm going to do is set my scale. And that means that I'm going to try to use as much of this graph that has been provided as possible. So there's a trick that you can use that you've probably learned in your math classes to help you with this idea. And that is, it looks kind of like a lightning bolt. So when you start your axes at 0, you can put a little break on the axes to let the reader know that you're going to skip some lines or skip some numbers. So what I like to do to scale appropriately is I like to look in my data and try to figure out what's the highest value I'm going to need and what's the lowest value I'm going to need. So the highest value I'm going to need is going to be 20.2. So because it's going to go as high as 20.2, I'm not going to be able to use this the way it is. Otherwise, I'd go above the graph and that won't count. That won't get graded. The lowest value that I'm going to need is going to be 17.2. So it looks like I could probably start at 17 and then scale from there. So this is the scale that I have decided on. I'm starting at 17 because I know my lowest value is going to be 17.2. Each of these blocks is worth 0.2, and I can make it all the way up to 20, including past 20, which is my highest value. The next thing I'm going to remember to do, because we've already done the S for scale, next is labeling the axes. So along the y-axis, this is going to be the average hand size in centimeters. And along the x-axis, I'm going to put 2 bars. We are comparing 2 different types of categories. And so I'm just going to label it with the name of the categories, and that's going to be enough. So we have XX and XY. So now that I have both of my axes labeled, now I'm going to work with the actual data itself. Now, I find that the easiest thing for students to do is to first go in and draw simply the bar graph. Nothing else. Just go in and put the bar graph. Again, it's a skill you've already done numerous times, and it's a great start. So here's my starting data with just the averages, 17.8 for XX, 19.4 for XY. Now what I'm going to do is I'm going to go in and draw the SEM bars. Now to determine the SEM bars, you need the information that's given to you on that sheet. So here's what we were given. We were given the average for the 2 sets of individuals, and then you have a number here. You have a symbol, plus or minus 0.6. This information right here tells you how high up and how far down you are going to draw the SEM bars. So from 17.8, we're going to add 0.6. That's going to be the top of the SEM bar. So that comes out to 18.4. So I simply added 0.6 to 17.8. 18.4 is what it comes out to. So now that I drew the top of that SEM bar. Now I'm going to do the same thing, 17.8, but this time I'm going to subtract 0.6 to find out how far down to draw the bottom of the SEM bar. And so 17.8 minus 0.6 comes out to 17.2. So starting from here, I went down 0.6, and that's where that line would be. So now I'm going to do the same thing with the XY. Only this time, I'm going to use 0.8 as my standard deviation. This will always be a standard error of the mean. This will always be given to you. So now I've gone in and went up 0.8 and down 0.8 from the average for the XY individuals, and now my graph is complete. The last thing I need to do is just write an appropriate conclusion. Now, in the conclusion, there's two parts you need to include. You need to talk about whether or not there's a statistical difference, and then how do you know there's a statistical difference? So what you look for is, does the top of this bar share any numbers with the bottom of this bar right here? So we're looking at the SEM bars, and we're looking for any overlap. And as you can see, there is no overlap. In fact, 18.5 is in between these two. So this one does not go high enough to go into this range, and this one does not go low enough to go into this range. That means there is a statistical difference between these two sets of data. So the first thing you're going to need in your conclusion again is there a statistical difference? We're looking for this word. It's very important that you include statistical difference. This is not just any old difference, it's a statistical difference. Very important that you use that word, statistical. Then in the second part of your conclusion, you're going to justify how you know it was a statistical difference, and that's where you talk about the SEM bars. And that's it for the conclusion. That's all you're going to need. I hope this video was helpful to you all. Thanks so much for watching. Bye.